So let's think about t-tests. T-tests and how to interpret p-values. So when you run t-tests in Stata, you're always going to get sort of like the output here, and then you'll have like an h0 that says mu1 minus mu0 is equal to 0. And then you'll have an h alternative, will be 3 of them. So they could be mu1 is less than mu0, could be mu1 is different from mu0, could be mu1 is greater than mu0. Okay? And for each of these alternative hypotheses, when you connect this h0 with this h alternative, you have a hypothesis test. When you connect this h0 with this h alternative, you have another hypothesis test. So what Stata is doing on that t-test is effectively running 3 hypotheses. 2 one-sided and 1 two-sided. Okay? The two-sided one is here. Two-sided. And then Stata is not making a judgment about what the significance level of this hypothesis should be. It's saying, I'm going to leave this to the reader. So what Stata is giving you is what are known as p-values, right? So what are known as p-values? So you get a test statistic here, test blah, 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 right? And what Stata is giving you is the probability that that test statistic is, or that the t-value, the test statistic is lower than the realized t. So think of this as a random variable. Think of this as an actual value that comes from this bit here, right? So this is saying how likely is it to observe even more extreme values. What do you mean by extreme values? Extreme values that support the hypothesis that mu1 is lower than mu0, okay? And it's one-sided. If you get something here like 0.83, okay, then what that really meant is something like this. Your t, which is centered around 0, and let's say for a second, even though this is not entirely clear, but let's say that the rejection region on this hypothesis, let's take a significance level of 5%. Let's say this is a left tail, okay? Let's assume this is a left tail, and this thing here is a right tail hypothesis. The significance level at a 5% would be here. So you'd say this is my 5%. If I fall within that region, if my test statistic falls within that region, I will reject my h0, right? In favor of mu1 is lower than mu0. That's what I'm doing, okay? Now, this p-value of 0.83 tells me that my t statistic was actually somewhere here. This was my t. And then the probability of being to the left of this t is 83%. So how do I decide whether to reject or accept this? Here's how I do it. If the p-value, so this is a p-value, this is p-value, if p-value is higher than the significance level, higher than the significance level, what do? I fail to reject the h0, right? I fail to reject. And if the p-value is lower than the significance level, I reject, fail to reject, reject. Okay. So of course the t-test is staying the same, right? The t-test, the t-value that you got is staying the same even for this hypothesis test. So if I were to kind of cheat here, even for this hypothesis, my picture would look the same with one exception. My rejection region now is going to be both-sided at 2.5% now. So I'm going to have 2.5%, and I'm going to have here 2.5%. Okay? My p-value now, my p-value, as you will notice, now is going to be something like this. Probability that the t, right, that the t, that the absolute value of t, okay, is greater than t, is equal to, maybe here you'll find something like 0. I'm making this number up, 12. What does that mean? That means that if you mirror this t because of the absolute value, and you do it here with minus t as well, okay, and you calculate the probability of being to the left of this and to the right of this, that probability is 12%. So this probability here is 12%. What does that mean? It simply means that the way I interpret that would be my p-value is higher than my significance level, so I fail to reject the H0. What if my significance level was 15%? Sure, then you'd say at a 15% significance level, you would reject the H0. But you don't have to do that. You could just say, I'm going to report the p-value. The p-value for this test is 12%. Right? So if I had a significance level of 12%, I would just about reject it. Okay? And can anyone make a guess on what this third graph would look like? What would this third graph look like? Well, it would, again, look exactly the same because it's the same type thing. The t hasn't changed. But then this, the rejection region of the 5% will be somewhere here. Okay. Again, what do we do here? We fail to reject the H0. The red bits are red zones, rejection zones. Okay. I'm going to stop here. I'm going to give you 2 minutes, and I'm going to take questions that you have on that.